Hi, this video will take you through the first steps of creating your own smart contract using the DasContract Editor. If this is the first time you are hearing about DasContract, please visit the article and GitHub repository in the description, which introduces the DasContract language and the aim of the project. If you are using the Chrome, Edge or Safari browsers, you can add the editor directly to your device and launch it directly in a native window. It will also function fully offline. When opening a contract for the first time, you have three options. You can create a new contract, upload an existing DasContract file that you may have received from someone else, or you can browse the example contracts. Let's open an example contract of European elections. The editor consists of three primary sections: the process model, the data model and the user model. Let's begin with the simplest one, the user model. It allows you to define the users and roles of the contract. Users must be assigned a concrete blockchain address and can have any number of roles. If you accidentally perform an unwanted change, you can undo the action using the Ctrl+C shortcut. The data model allows you to define the data structures that will be used to persist and manipulate data in the contract. It is declared in a XML structure. The right side of the screen provides a visualization of the data model. The ratio of the text editor and model preview can be customized by dragging the divider. You can also download the diagram. The entity data type serves as a container for data properties. When defining properties, you must specify the data type of the property. The available types are integer, unsigned integer, boolean, string, datetime, address, byte, or reference. If a property is of reference type, it must also define the enum or entity it is referencing using the reference data type notation. You can also specify whether you want the property to be an array, dictionary, or single. The default property type is single. You can also set whether a property is mandatory and must be specified when the entity gets created. One of the entities may also be defined as the root entity. The properties of the root entity will be placed directly into the contract and will be accessible using scripts. Another data type you can define is the enum. It simply allows you to define a list of enumerables, which can be referenced from entities using the reference type property. Lastly, the token data type can be defined. It allows to define tokens you'd like to create in your smart contract. You can specify fungibility, issuability and the symbol name of the token. Next, you can specify the logic for minting and transferring the token. Similar to entities, the token type can also contain a list of properties. The process model allows you to visually define the flow of activities in the contract. New process elements can be added using the toolbar tray in the left edge of the screen. Clicking on a process element brings up a detail sidebar, which is used to edit the properties of the process element. The detail bar can be resized by dragging the divider. Every process flow must begin with a start event and end with an end event. To direct the process flow based on a condition, an exclusive gateway can be used. The condition is defined and the outgoing sequence flows in the form of a script. The script can reference any data structures defined in the data modeling section. To branch the flow into parallel execution flows, a parallel gateway can be used. Two primary types of activities are currently available: script tasks and user tasks. Script tasks allow to define a custom script and execute automatically whenever the flow reaches them. They can, for example, be used to access the persisted data types to conditionally validate or modify data, or to send funds. Arguably the most important activity is the user task, as those define the interaction with the deployed contract by the participating parties. The rights to trigger a user activity are specified using the assignee, candidate roles and candidate users fields. Only a single user assignee may be defined, but multiple candidate roles or users can also be defined if need be. The input fields of the activity can be defined using the Forms tab editor, which allows to design user forms in a simple XML-based language. The whole form can be split into a list of field groups, each containing a label and a list of input fields. Currently, the user may define date, address, single line, multi-line, integer, decimal, boolean, enum and drop-down fields. The user task may also define custom scripts that can be used for validating the input fields and assigning them to the data model of the contract. The process model may also be further split into multiple subprocesses by selecting the process pool element. The processes contain an as-executable property, which is used to mark the entry process of the contract. Only one process with this flag is allowed. Non-executable processes may be called from other processes using the call-activity element. Similarly to the data model diagram, you can also separately download the process model diagram. If you need to save your changes, you can either save it directly in the application, or download the DasContract file. When a contract is saved directly in the application, it can be later reopened from the landing page. When you are done creating your contract, you can convert it into the target blockchain platform. If the conversion is successful, then the contract code is displayed and can be downloaded. If conversion is not successful, an error prompt is displayed, describing the issue. Let's try to design a simple contract, where two participants play a game of rock, paper, and scissors. Let's begin by defining the users of the contract. Let's say Alice and Bob are playing. We fill out their name and blockchain addresses. Next, let's define the data model. We will need an enumeration that contains the possible choices, rock, paper and scissors. We will also need a special state none, if the player fails to make a choice until a given deadline. Next, we define a root entity to persist the workflow data. We will need to persist the choice of Alice and Bob. A special property is also used to track whether the game is over. Lastly, we need to define the process model. We will permit multiple games to be played if a tie occurs, so let's extract the round playing into a separate process. The players can enter their choices independently of each other, so the flow needs to be split using the parallel gateway. We will create a user task for each player and assign the respective user. Next, we will define the form the players will use to input their choices. It will contain a single enum field, listing all of the options. The enum field will also be marked as indexed, which means that they will be inputted as unsigned integers. The options are numbered in the order they are defined, starting from 1. In the blockchain code, this will create an input property called named after the label, in camel case, so we can access this property in the validation script. In the validation script, we access this property and persist the choice of the player based on the inputted property. Lastly, we need to synchronize the parallel branches back into a single execution flow, to ensure that both players have finished their turn before evaluating the answer. To ensure that the contract execution does not get stuck forever, in case one of the players refuses to play, we can attach a timer boundary event to both tasks and define a deadline date. If the player does not complete the task until the defined date, the task gets interrupted and execution continues in the flow defined by the boundary event. In this case, we route it into a script task that sets the choice of the given player as none. Let's return to the main executable process. We will call the round process using the call activity. The call activity will wait until the called process reaches an end event. After that, we can evaluate the results using a script task. If a tie happens, we set the game over property to false. If both players fight to input their choice, then the game ends in a stalemate. Otherwise, one of the players wins and they can receive their prize. Lastly, we use the exclusive gateway to determine whether the contract should terminate, or loop back to the round process, using the game over property. The conditions are defined on the sequence flows. With the contract done, we can convert it into Solidity and deploy the code onto the blockchain. Thank you for watching.